Let's proceed by looking at three types of cloud services. The first one is compute service, then storage and database services. Let's start with the first one, the compute service. We define this as cloud services that provide dynamically scalable compute capacity in the cloud. You already know that what we mean by computer capacity is the ability to run applications, and this is normally you associate computations with the computer CPU, and the overall package is basically the computer. And so these compute services are normally can be provided as virtual machines. And by the way, you can make a request for these services. So these are provisioned on demand. You can also, once these are created in the cloud, there are various ways in which you should be able to access them from anywhere, from any location, far away from where it is actually located. So you can access these through web consoles with a graphical user interface, and also and that interface would allow you to provision the machine, to manage them, and to monitor them. Right. There is another more powerful mechanism that allow you to access these services. There's programming. This is referred to as API, or application programming interfaces, and they may be provided for various programming languages like Java and Python to allow programmers to access and manage these compute services programmatically. In this course, we will look at Python as our main programming environment for performing these. So the Python library provided by Amazon AWS, which has been called Boto. It's not quite clear why it is called Boto. Boto, BTO, Boto 3. I'm not sure whether they will now have Boto 4, but that would allow you to programmatically access not only the compute services, but other services like storage, database as well. Right. The diagram to the left shows you the spectrum of compute services that you find in the cloud. This is a pyramid that has the bottom as the infrastructure as a service. Ideally, this is at the bottom mainly because all the others are actually built on top of the infrastructure as a service. The infrastructure services provides virtual machines, but above that you can also build on top of that containers, which can provide it as a service. Many of you are familiar with Docker, the Docker container engine. So containers will allow you to run a particular application. It contains all the dependencies for a particular application to execute. So containers are very important as compute services as well. Then applications as a service. This is where the cloud itself provide an application like Google, like Gmail, where you can particularly just use the email system. Whereas in containers, you could run basically any type of application, including development environments. So applications as a service is also a compute service because there is some computation going on. You can run your application, and functions also can be run in the cloud, and that leads to what is called serverless computing. So in that case, it's as if you do not have and you don't need a server, so it's referred to as serverless computing. Right. This infographic summarizes some of the cloud-based environments for running your application, and it summarizes that similar to the pyramid that you saw. You have the compute engine, Kubernetes or something like that. I don't know how you pronounce that. You have engines that have containerized applications, which is basically used for multi-cloud deployments and strong pipelines as well. And of course, you have serverless and clusterless apps and containers. In Google, they have Cloud Run. You use this for fully managed infrastructure with rapid auto-scaling and so on. Then there is a Cloud Functions, of course, which is used mainly through event-driven cloud automation. Because if something happens in a cloud, you can basically invoke a function to execute something. So it's also a compute service. So the ones that is probably more familiar with you guys is where you run a virtual machine in a cloud, which is the compute engine. So you do require some of these engines. So the infographics is done by Priyanka Vegadia. Some of her infographics, we may use some of these because they summarize very well some of these aspects of the cloud. Priyanka Vegadia focuses basically on cloud computing. So he draws these infographics mainly from a Google perspective, although we can see that they are good examples of some of the theoretical perspective to the work. And of course, we might be borrowing throughout this course some of the infographics, which are a good summary of some of the cloud principles that we may want. Right, now let's look at key services for compute service. These are quite common. The key features of compute services may also be found in all the other cloud services. For instance, scalability. This is rapid provisioning as demand increases. We emphasize that it's different from elasticity, of course. Then you also have a flexibility. In other words, there is a wide range of options. And then security, various security technologies can be used by the compute service. Then cost effectiveness. Of course, there are various billing options, which brings down the cost more. Now let's look at the next type of cloud service, which is the storage service. It allows storage of any amount of data at any time from anywhere on the web, and data is organized into some kind of containers. And the term for these containers differs from provider to provider. Some call them buckets, some call them simply containers, some call them something else. But basically, these are units of storage. So the key features, again, you'll find some are common across a number of services. Things like scalability. Replication is unique to storage, but it is also important to databases as well, database services. Replication is where you duplicate the data to allow recovery in case of failure. Access policies relate to security, encryption also. Then things like consistency is very important for the storage as well as databases. Right. The diagram on your left is a general high-level cloud storage architecture where you normally have a public API that allows programmatic access to the storage mechanism. And then, of course, you have the public API leads you to logical storage pools. Notice that virtual compute servers are becoming important to allow manipulation of the data that is stored or objects that are stored. Right below the logical storage pools, you have the physical storage servers, of course. There could be several of these, and they can be spread across various locations. So this is a general concept on how the architecture of cloud storage systems. Now let's look at the final type in this section, which is database services. It allows one to set up, operate relational or non-relational databases in the cloud. So when you have a database service, developers are freed from the job of the database administrator. You don't need to perform DBA. At least some DBA roles, not necessarily all of them. And also you have popular relational databases like MySQL, Oracle relational database, and SQL Server. Of course, there are others besides the ones that we have listed here. Typical examples are Postgres SQL. You may also have DB2 by IBM and SAP, of course, SAP database. Non-relational databases are mostly proprietary, fully managed, and deliver seamless throughput and scalability. And they are very popular for those who are dealing with proprietary data. Right, key features, yes, they are general. Of course, you need scalability, reliability, performance, and security. Of course, I believe in databases we may need the replication may be managed in the cloud generally. Right, again we have Priyanka Vegadia's infographic, which clearly summarizes the other one, the database, the relational, non-relational, and also a third type of database that we had not mentioned, that these are in-memory databases. Typical examples are Reddish and Memcached, and also it allows sub-milliseconds data access because it's stored in memory. It's fast to access it, so you use this especially for in-memory, especially you want speed of access and read-write access, and also if you want to use key value stores, use caching. Typical examples of these are session store, personalization, gaming, leaderboard, social charts, and so on. The others have got use cases that you guys are familiar with, like relational databases are good for web frameworks. They've been used a lot for the web, software as a service applications, whereas non-relational ones are important for big data, and big data is normally associated with Internet of Things. Recommendation engines also use non-relational databases together with operational personalized apps rather. Right, that's the end of section 2. In section 3 we look at the next type of cloud services, that is application services.